This is Rutgers Capstone Group S19-46, and our project is a RISC-V compliant CPU core running on an FPGA. This core was written from scratch in VHDL based on the RISC-V specification. It's an RV32i 25 MHz core with a single issue in-order 5-stage pipeline. For our implementation, we loaded the core onto a Digilent Zybo development board featuring the Xilinx Zinc 7000 FPGA. The core has 32 kilobytes of instruction RAM and 2.4 kilobytes of video RAM for drawing to a terminal. For our examples, we've integrated the push buttons and switches on the board for user input. It includes a graphics unit that outputs to a VGA monitor at 640 by 480 at 60 frames per second and can display 80 by 30 characters. We'd like to showcase the sample programs we wrote for the core. The first demo program is Rock, Paper, Scissors. This demo showcases the use of a random number generator written in RISC-V, and how it can be used to implement a computer opponent for the game. The player can choose between rock, paper, and scissors for each round, and play against the computer opponent. The game also keeps score for both players. The second program we wrote is a terminal maze. This program shows that the core is capable of utilizing the entire screen, and can manipulate memory to do collision detection between the player icon and the walls of the maze. The user can push the buttons on the Zybo board to move their player icon through the maze, with the goal being to reach the end. The third program is a benchmark. This demo runs 2 processes of the same length on the core to demonstrate that a pipelined architecture does more per clock cycle than a multi-cycle architecture. The first progress bar generates hazards that emulate multi-cycle execution. The second bar uses the full pipeline without any hazards, and it's clear that the difference in speed is significant. We found the performance to be about 3 times faster for the pipeline benchmark compared to the multi-cycle benchmark. Thank you.